Well, welcome back to GIS Analysis at the University of Alaska Fairbanks. From last session, we have two simulated rasters from LIDAR. We have a last return raster representing the ground surface and a first return raster representing the elevation near the top of a canopy. So next what we want to do is create a raster of the canopy height. So if we subtract the first return minus the last return, that will give us a raster representing canopy height. So we can do that using either the raster calculator or the minus tool. So if we take the first return minus the last return, that will give us an estimate of the canopy height. So you notice that we have some negative values. So those are sort of artifacts of just random errors in our first return raster or minor errors in our last return raster. So the next step is, if we have a value that's negative, let's turn it into no data. So we can either use the set null tool or the con tool to turn these values into no data. So I'll use the con tool. So we don't have any attributes because we don't have a raster attribute table, so we have to type it in. So value is greater than or equal to 0, and if that's true, we'll keep our canopy height. And then we'll output that as canopy height underscore no data. So now we have appropriate values. A low would be basically the ground surface, to a high would be the top of the canopy for a spruce tree, about 30 meters. Now let's say we want to locate all the spruce trees that have a canopy height above 25 meters. So to do that, we could use the con tool, and we could ask the question, is the height above 25 meters? So is the height or the value greater than or equal to 25 meters? If it is, let's make it a 1. And then we'll output that, we'll call it tall pixels. And then greater than or equal to 25 meters. So if we look at the attribute table, we've got 10,475 pixels that are above 25 meters. Now some of those pixels will be from the same tree. So what we want to do is we'll get groups of connected pixels that are above 25 meters, and we'll consider that from the same tree, because we could have a tree crown that's way bigger than 1 square meter. So we can use the RegionGroup tool to group these values into groups. So I'll output it to a raster called tall groups, and then if it's connected in any of the 8 possible directions, we'll consider it a group. And then they don't have to be the same value. And then we don't need a link. So we started with over 10,000 tall pixels, and then we end up with about 4,600 tall groups. So then we can convert these tall groups to tall polygon patches. So we use the raster to polygon tool to convert our tall groups into tall patches. And if we zoom in, we can see here's a tall patch. It's just one continuous patch that's connected. Here's a tall patch, etc. So then our final step is, what we would want to know is, what's the minimum and maximum elevation within each of these tall patches. So to do that, we can do the zonal statistics as table, where our zones will be for our patches. So zonal statistics as table, for each polygon that has a unique ID, what is the canopy height? And then give us the minimum, maximum, and mean canopy height within each polygon, and that will give us some statistics. I name my output table patch stats. So our output table, we have the minimum, the maximum, and the mean. And if we do statistics on the minimum field, every patch should have a value above or equal to 25. So here is the minimum of all those patches, 25 meters tall. So then we could use join field to transfer these values into our polygons. So we're going to transfer from our table to our tall patches polygon, and we'll transfer the minimum canopy height, the maximum canopy height, and the mean canopy height using the field ID and ID as a key field. So now we have for each patch, the area of the patch, the average canopy height, the minimum canopy height, and the maximum canopy height. And then our final thing, we might want to say, well, we're only interested in really large patches that are tall. So let's, for example, only be considering patches that have an area above 5 square meters. So we can do a definition query, shape area above 5 square meters. So here are the patches where the shape area is above 5 square meters.